Hi everyone, this is Mr. Jones again. This is the second video on naming compounds. Just to have a look at our objectives from last time. We looked at naming compounds and we looked at some revision on valency and charge. Today what we're going to look at is we are going to look at rules for naming ionic compounds and the tricky rules for transition metals and for polyatomic ions. Okay. Right, so the general rule that we have, or that we're able to use rather, is that elements when they're reacting, they like to fill their octet and they like to be in the lowest possible state of energy or a ground state. And we can, from that, we can be able to explain why our metals and our non-metals form their anions and cations respectively. So our general rule is that non-metals accept electrons and become negative anions. Negative ions. Whereas metals tend to give away electrons and become cations, positively charged ions, right? Okay, and as I said, during reactivity and the elements generally want to fill their orbitals and form an octet, and this is very stable or ground state. And as we know from our, if we're looking here in the periodic table, as we know from our noble gases, that they have their octet or this their outer orbitals filled with electrons, so that makes them very stable and unreactive, right? Keeping this in mind, moving on to our sorry, back there. Keeping this in mind, moving on to our ionic bonding, our naming of compounds and ionic bonding. We have the following rules that we need to follow. So we know that the first rule is that with naming ionic compounds, we know that there is a metal and a non-metal that are reacting together. And in this case, as you see from our general rule, our non-metal accept electrons, and our metals give away electrons and become cations. And obviously our non-metals become the anions. Second rule for ionic compounds is the non-metal gets an ending of IDE ending. And we'll have a look at some examples after we've gone through all of the rules for our naming of ionic compounds. Next rule is the transition metals. Let's just put ending in there so you can see it nicely. So for our transition metals, these metals over here, you should know by now. For our transition metals over here, they make things a little tricky for us, and they have different oxidation states. These oxidation states just refer to the different number of valence electrons, as we discussed in the last lesson. So how do we deal with them? We deal with them by using Roman and Greek nomenclature, and most often we make use of Roman numerals. Okay, and just up to 1 to 7, that would be 1. The symbols for them, it's 2, 3, 4, 5, 6, and 7. Okay, and these Roman numerals will be placed just after the metal. So we'll have our metal over here that's combining with our non-metal, and we'll have our Roman numeral set right in over here, and explaining to us what the valence or the number of valence electrons that the metal has, and that will be represented by 1, 2, 3, 4, 5, 6, 7, etc. Right, the next rule for naming ionic compounds, our next rule is also referring to the Greek and Latin nomenclature, and that is the use of the ending IC and OUS. Now these endings and this Roman or Greek nomenclature, these are ancient terms for the different elements. So for example, if we take iron, the iron's name is ferrous, and another example would be copper, and its ancient name would be cuprous, and lead, its name is plumbus. But now the use of the ICE and the OUS ending, as you can see, the ending of the word, that now is also a way for us to indicate the valence, the valency of the metal. So these two will help us to identify valence. So ferrous would be the higher, sorry, the lower charge, and then if it is ferric or cupric or plumbic, that would indicate the higher charge. So ferrous, these would all obviously be positive, both be positive charges, because the metals give away their electrons and form positive ions. So if we had iron 1 oxide or iron 2 oxide, that would, or iron 2 oxide and iron 3 oxide, that we would be able to determine by identifying this OUS and IC ending. Obviously, this OUS, sorry, the IC will be the higher charge, and ferrous or cuprous or plumbous would be the lower charge. Okay. Right, our next rule that we're going to look at is the polyatomic ions. This is going to be rule 6. Oh, I left out a rule here. So just another quick rule that I need to add after this. Rule number 5, sorry. Rule number 5 here for naming our ionic compounds would be the metal comes first. Always. And when we have a look at it later, when we've got two metals combining or two non-metals combining, it'll always be the one with the lower number of valence electrons. So back to this valency concept again. So on to our 6th rule with polyatomic ions, also referred to as oxyanions.